Hello, good morning, good evening. We are about to start with a new session, and this session is on Snowflake versus BigQuery. So I'll go ahead and share my screen. So I hope you can see my screen, and I will turn off my video so that we can completely focus on the core topic that we are about to cover. So let's start with this interesting topic. Good morning, good evening. We are about to start with a new session. There is an echo. I'll close the browser tab, and now we are starting with this session. And this is Snowflake versus BigQuery. So both these topics are very close to my heart, and I love both the technologies. So the views that I'll be presenting in this particular session, it will be purely my personal views, and it will not be like anything specific to Google Cloud or anything specific to Snowflake, like as like organizations. So they have their own way to share knowledge about Snowflake and BigQuery. But in this presentation specifically, when I am sharing anything, so first of all, I am clearly sharing this part that it is a disclaimer that the views that I'm having in this presentation, it is based on the experience and the feedback that I receive from different training participants and also the experts working in different domains, different companies using different technologies, like including Snowflake, Teradata, Redshift, BigQuery. So from different experts, gather a lot of inputs, and based on that, I will be presenting this. So these views are not from Snowflake or Google Cloud. And when you have to decide your data warehouse, then you should take informed decision. So you should do the due diligence specifically and look into various factors before you decide a specific data warehouse. So with this disclaimer, I would like to start. And in this presentation, we will be looking into different aspects through which we will be comparing these two data warehouses. And before we go into the formal presentation, let me talk about myself. So I'm 𝐜𝐿𝐴𝐺𝐻 Chawla. I have more than 18 years of experience working in different technologies, worked in different domains, including cloud, machine learning, AI, big data science. Apart from that, like I'm also an official instructor for Google Cloud, Snowflake, Confluent, and many other companies. And I have delivered sessions for many companies, including Google Singapore, Microsoft Bangalore, Starbucks Coffee, Adobe, and there are many other Fortune 500 companies. I was recognized by Cloudera as the Instructor of the Year 2016. So that was an APAC level award that I got. And I was recognized by Pluralsight as an Elite Instructor in 2020 and 2021. So our company is primarily into enterprise trainings, and we also provide architectural consulting and agile consulting. So we are into different domains, and these are mostly Web 3.0 technologies. So we have delivered workshops across globe, and then we have trained 100K plus participants. So these participants are in various courses, including self-paced courses, live virtual instructor-led classes, and it is also in-person workshops that we delivered. So recently we got recognized by Confluent, and this is the award that this is the award that we received from Confluent. This is Education Partner of the Year. So this is a recent achievement that we got from Confluent, and we were also covered by CIO Insider magazine in 2021. So these are some of the glimpses of the workshops that we conducted across globe. So we have a meetup group, which is All Things Data, and it is having 3,700 plus members. So please join this group in case you are not part of this meetup group. It is more for social contribution. And we have LinkedIn page where you can get updates about the latest, greatest things which are happening in technology. And we have 3,000 plus members here in the LinkedIn. So please join that. And then we have a YouTube channel where you will find videos related to these technologies. Even this particular meetup is being live streamed to YouTube. So before we start, I would like to start with the timeline of Snowflake, and I would like to start with timeline of BigQuery, and then we will be looking into why Snowflake, why BigQuery. So just to give you a holistic perspective, yeah. So Snowflake started as a stealth startup in 2012. And in 2014, Snowflake generally became available, and it onboarded, like Snowflake company onboarded a first customer. And in 2016, there were some interesting features added in Snowflake. So if you see, like there are events which are happening since last 10 years or more than 10 years now. So 2016, so this was an interesting event which happened. Like we can see, like query profiling and multi-cluster warehouses were introduced at that time in 2016. So I'll talk more about it when we move forward. But this is a basic assumption that you have some understanding of Snowflake, because then only the comparison will make sense. In case you are not having background of Snowflake and you are watching this video, so I would highly recommend go to our YouTube channel. So this is our YouTube channel. If you go to 𝐜𝐿𝐴 YouTube channel, you will find we have many videos related to Snowflake. So just search for Snowflake. You will find we have some basic videos like getting started with Snowflake or Snowflake architecture. So there are many videos that you can find on our YouTube channel related to Snowflake. And also you can find videos related to BigQuery. In case you are not having any background of Snowflake or BigQuery, then you can just visit our YouTube channel, and here you can find videos related to BigQuery or Snowflake. So please do watch those things before you move forward, because this session is having an assumption that you are already familiar with BigQuery and Snowflake, and now we are in a comparison mode instead of learning the technologies from the scratch. So you will get maximum value when you already know basics of these technologies. So 2017, Snowpipes, secure data sharing, single sign-on support were added. So apart from that, like 2018, Snowflake started to work on Azure also. So what happened, like initially when Snowflake started, it is basically Snowflake on AWS. So this is all AWS. Since inception, Snowflake is on AWS. But 2018, Snowflake also started to work on Azure platform, Azure cloud. And then 2019, Snowflake also became compatible with Google Cloud Platform. And 2021, another interesting feature was introduced, Snowpark, and I will talk more about it. But right now, this is the holistic perspective how Snowflake is evolving over last few years. So you can see AWS is there since inception, and we have Azure in 2018 and 2019. So when some cloud provider is already there since beginning, so you can understand like there is a lot of support which is already available. So if you go to this website, which is Snowflake status, or you can say status.snowflake.com. And on this website, you will see which all regions support Snowflake. So you can say if you are working with AWS and you want to run Snowflake with AWS, then you will see so many regions are already supported. So many regions. And if you are working with Microsoft Azure and you want to use Snowflake with Microsoft Azure, then these are the regions which are supported. And 2019, when Google Cloud was introduced, so this is comparatively a newer development. So you can say 2019, there are only 4 regions which are there in GCP. But since AWS is there since inception, so that's why there are so many regions which are supported for Snowflake. So this is one important information that I wanted to share with you. By this way, you can also see the status if the service is running or not. So this is an interesting and important link. And if you can go to this another this page in the documentation, then you will see that different regions where Snowflake is available, and this is more like a map view, or like you can gain better understanding, and here you can get much more information about even about the pricing and other things. So the additions of Snowflake and lot of other interesting details in case you are keen in knowing more about it. So this was high level view, but this one is much more detailed view about the regions that we have. Okay. Now, anything that you have in your mind, feel free to ask, feel free to clarify. I may not be able to check the questions on the YouTube. Maybe my team can help me in sending those questions over the chat. But if you are joining through Zoom, then I would encourage you to ask questions and clarify things then and there itself whenever you have anything in your mind. Yeah. So this is evolution of Snowflake, and we just related with the regions that we are having, and for AWS, Snowflake is having the best support, if you see, because it is available in so many regions. Now we have BigQuery. So when we say BigQuery, BigQuery evolved, and again, like it is more than 10-year-old. It's not something new, and Snowflake is also not very new as such now. It's already started in 2012, so you can say more than 10 years. But the first customer which was onboarded was in 2014, so you can say approximately like 9 years. So this is like more than 12 years old. So BigQuery alpha version was released in 2010, and 2011 BigQuery version 1 was released. So this is non-standard SQL. So that means you have to learn the BigQuery SQL. This is legacy SQL. This is non-standard SQL. So you had to learn non-standard SQL, legacy SQL, and it was not very useful because now at that time, like people were more comfortable with the standard SQL syntax instead of legacy SQL. So that's why in 2016, BigQuery released version 2, which is like standard SQL based. And here there were a lot of other additional things which were released in 2016. So it became much more compatible with those people who are coming from SQL background, and you don't have to learn anything new. So ramp up or the learning curve was very low. And it started to be like adopted by so many people, business analysts, data analysts. So BigQuery version 2 is another important milestone where standard SQL was introduced. 2018, BigQuery introduced BigQuery machine learning. And this is another game changer, because till now we were analyzing historical data with BigQuery, but now you can also make predictions through BigQuery ML. So this is another important area. And then there were other additional things which were added in BigQuery, BigQuery Sandbox, BigQuery BI engine. So these are some of the interesting things. When I'm giving walkthrough of the UI, then it would make more sense to relate what exactly are these, but they are very helpful in integrating with business intelligence tools. So we'll look into that. And then 2021, BigQuery started to offer a functionality called BigQuery Omni. And this is something which is for supporting multi-cloud strategies, because a lot of people say that BigQuery is only for GCP, but that is not the actual case. BigQuery also offers BigQuery Omni, which is again multi-cloud analytical solution. That means like if your data is available in AWS or your data is available in Azure, then also we can fire queries through BigQuery Omni. So this is an interesting feature, but again, there are a lot of limitations. So I'll show you this product when we are comparing BigQuery and Snowflake in more detail. And then there are other interesting things which were added in 2022. So when I'm looking at this like analytical hub and analytics hub, so this is more like data sharing, like you can collaborate, and you like within your org, you want to share data with your different teams, and like even you can make it public. So we have this big lake, which is like a data lake and data warehouses combination. So it is supporting that. So a lot of interesting things happening in both the technologies. And I'm not saying that 2021, after 2021, nothing happened in Snowflake. A lot of interesting things are going on in Snowflake, and these things are related to new things, like related to data governance related stuff, including access history, object dependencies, row access policies, and a lot of interesting things are happening here. And even Snowpark is now generally available. Earlier, it was in 2021 when it was released, it was just in preview mode, but it is now generally available, Snowpark. So a lot of interesting things are happening. So it doesn't mean that 2021, after that, nothing happened, but a lot of things are happening, but just that we are having time constraint, and also we need to cover so many things which happened till now. First, we will focus on those, and then we can even discuss about the latest, greatest things. It may need another meetup to talk more about the differences between BigQuery and Snowflake. But for the time being, I'll get started and give you the holistic context and the key comparisons between these two platforms before we move into the latest, greatest things, which are recently happening, and they are still in preview mode. Okay. So now I will move to whiteboard, and again, there is a request to follow LinkedIn page for getting future updates regarding such sessions. So there is a trend which is going on. One thing is buy a car, another thing is rent a car, another thing is hire Uber. So renting a car, hiring Uber. So these are the trends which are going on. So buying a car is like we are having our own data warehouse, and you are buying a car. That means like you have to spend a lot of money, and here you have to maintain the car, you have to monitor the car. If there is any problem with the car, then car will be unavailable. Maybe it is in the service center and we cannot use that car. So there are many issues with buying a car. But renting a car and hiring Uber, these are the common trends which are going on. So renting a car, that means like you get a car for a day and then you pay rent for that entire day. Yeah. So that is renting a car. And hiring Uber, you're paying for the usage. You pay for the trips that you are making. So we'll see Snowflake, BigQuery, how they are related to this analogy. So we will be looking into that, and where Snowflake is like renting a car and where Snowflake is like hiring Uber. So we will look into these things. Okay, I'm moving forward. So what are the common things between these two technologies? So one thing is like BigQuery and another thing is Snowflake. Both are shining these days, and not just these two technologies, but there are other platforms also, like Azure has its own Synapse, and there are other platforms also which are shining. But right now, since the agenda for today's discussion is to focus on BigQuery and Snowflake, so I'll stick to that. And I want to mention, before we go into the differences between these two platforms, I would love to talk about the key features which are basically helping both the technologies to shine. So very first thing that I want to mention here is decoupled storage and compute. So initially when Hadoop started, and even today when you are having on-prem Hadoop and you are not creating ephemeral clusters on GCP, then it is like coupled storage. That means data locality principle. That means storage and compute both are on the same machine, like if you talk about on-prem Hadoop clusters. But when we talk about BigQuery and Snowflake or the cloud-based technologies or cloud-based data lakes, then you will see that now there is a concept of decoupled storage and compute. So we want to keep storage separate. We want to keep compute separate, because by this way, we can scale both the things independently in a cost-effective manner. Yeah, so this is a quick summary how decoupled storage and compute helps. Then second thing is we are able to leverage the benefits of cloud, because both are cloud related technologies. Like BigQuery is also primarily running on GCP, if you ignore BigQuery Omni. And then we have Snowflake, which can run on different cloud providers, specifically three main cloud providers, GCP, Azure, and AWS. So you can say leveraging cloud. So that means cloud provides us infinite storage and compute, and the elasticity that we can get from cloud. So these are some of the benefits of having cloud-based modern data warehouses. And then there is minimal maintenance that we are talking about. So here, the role of database administrator is really reduced, and we don't have to worry about a lot of activities related to maintaining the data warehouses. Traditional data warehouses, it was very painful to maintain those traditional warehouses, but here we have minimal maintenance. Then it is also very cost effective. So there are a lot of case studies, and even you can also do a quick benchmark on both the platforms and see how much costing it will incur. But I will talk about the pricing part also in this meetup itself. Then there is secure data sharing. That means you don't have to move data from one system to another system or create multiple copies, and you can easily share the data in a secure manner. So there are many benefits of doing this. So you can share data with your clients, you can share data with your partners, you can share data publicly, you can share data with different departments. So that's why these technologies are shining, because data sharing is very easy. Earlier, sharing data was not easy with traditional data warehouses, because there were different versions of truth. So you are sending data to another department, they are working with different copy of data, and you are having different copy of data. It was not easy. And then access control, how we can ensure that, how can we achieve that? So these things were not easy. So if you go to our YouTube channel, you should be able to find a video on data sharing related to Snowflake. Yeah, data sharing in Snowflake. So I would encourage you to watch this video in case you are interested, because data sharing itself is at least a 1 hour long topic that we covered in this meetup. Yeah, data sharing in Snowflake. Please have a look. So coming back to this, secure data sharing is another important area. And then another important area is single version of truth with regards to data and metadata. So, query optimizer, when it is optimizing the queries, then it has to have access to the latest metadata information. So when I say latest metadata information, that means if you remember, like traditional data warehouses, we were having various commands, including analyze table, and we were like recalculating the statistics of columns and statistics of tables. So that was painful because that was manual process, or maybe after bad job, you were executing those commands in an automated way. But still, there was always a gap. Whenever data was stored in traditional data warehouse, then we had to update the statistics. So if statistics are not updated, then query optimizer was not able to generate an optimized plan. So that was the big problem. Now with Snowflake and BigQuery, the metadata is always up to date. So query optimizer will be able to generate optimized plan for your workloads, and data is also like at a centralized place. That means we have storage, and that storage is also centralized one. So that is another beauty of having this data and metadata. So that means like if you have a centralized storage of data, then all the departments, all the workloads which are running, for example, business intelligence team or data science team, so they are all working on the same data set. They will have the same version of truth. They will see same data. Yeah. Apart from that, support for semi-structured data storage and data processing. That means like BigQuery, Snowflake, they are storing your data, semi-structured data in an optimized manner. And the query optimizer is also able to parse that data. So it is not like a black box for your query optimizer. So in other data warehouses, you must have seen that maybe you are using binary, you are using blob, clob, or there are so many other data types for storing semi-structured data, which does not help actually to the query optimizer, and it cannot generate optimized plan for the nested data. But here we have that support. And then time travel, that means like you can go back in time. So let's say this is like an undo functionality. So you have made some mistake as a data analyst and you want to go back in time. So after maybe you deleted few rows and you want to recover those rows. So you can do that time travel. There are differences between BigQuery and Snowflake with regards to time travel. It's not not same in the sense like the kind of functionality that BigQuery provides or the kind of functionality Snowflake provides. I'll talk more about it. Zero copy clone. So if you want to clone a table, then it can be done very easily without having multiple copies. So you are not moving the data. So you are able to clone the table through metadata based operation. Yeah. So you are able to clone the table without any worry. And now in Snowflake, we have other features also, not just table, but other objects can also be cloned. Learning curve is low because both are based on n size equal. Like if you know that, then you can easily work with that. And there are many other reasons for using BigQuery and Snowflake, like security, and there are many other areas like data governance. There are many other areas where both the technologies are shining. So this is the quick background, like why both the platforms are shining. Now, what are the differences? We got it, like these are cloud-based technologies, and now we want to talk about the differences. So first of all, when we talk about BigQuery, we are talking about architecture which is like inspired by Google Dremel white paper. Yeah, so this BigQuery architecture is inspired by Google Dremel white paper. So let's go to the YouTube channel because I have already recorded a video for, so we have a video architecture of BigQuery. If you search in 𝐜𝐭𝐴𝐻 YouTube channel, you will see this is BigQuery architecture. And if you go inside this architecture, so this architecture, we can see we have like a petabit network, and here we have Dremel, Google Dremel white paper, and here we have the storage also. So if you see, we have this architecture. If you move forward, here I have explained in different manner, like, but I'm just thinking aloud, like take your own time, go through this video because it is something in which you need to just take a look at individual components within architecture, within this architecture. So this is storage and this is compute. And compute is inspired by Google Dremel white paper, and storage is inspired by 𝐜𝐭𝐴𝐧𝐧𝐞𝐜 white paper. But right now I have written specifically related to compute. So Google Dremel white paper and 𝐜𝐭𝐴𝐧𝐽 file. We can even write 𝐜𝐭𝐴𝐧𝐽 file white paper. Yeah. So it is inspired by Google Dremel 𝐜𝐭𝐴𝐧𝐽 white paper and 𝐜𝐭𝐴𝐧𝐽 white papers. Apart from that, like if you see, we have Snowflake, and Snowflake is a proprietary technology, and there are high-level white papers which are published. So let me collapse it and take you to those white papers. So let's go to the white paper of Snowflake. So I want to show you somewhere here. Yes. So this is a white paper. And this white paper, we have detailed view inside Snowflake. So I would encourage you to look at this white paper, go through this white paper in which there is an explanation given related to the Snowflake technology, shared nothing architecture. And then it is giving the holistic perspective and the context why Snowflake was built for the cloud and how it is helping. So this is multi-cluster share. So this is the architecture of Snowflake. So there is centralized storage, and then there is another layer. So this is centralized storage layer, this is compute layer, and there is cloud services layer. So this is multi-tier architecture. And here we can see we have compute. I'll explain it in more detailed manner, but just want to just want to relate that when we talk about white papers, on Snowflake website, you will find there are n number of white papers. There are white papers for Snowflake data sharing. There are white papers for Snowflake semi-structured data processing. So whenever you want to implement anything in Snowflake, I would highly recommend that you must read the white paper of the specific area in which you will be working in Snowflake. So just have a look, but this is a white paper which is a base or foundation. So I would encourage you to please go through this white paper first before you delve deeper into other areas within Snowflake. So this is like Google Dremel white paper, 𝐜𝐿𝐴𝐧𝐽 white paper, and then this is a white paper for Snowflake, and there are many other white papers. Now we want to see the architecture. It's important to understand the architecture of Snowflake and BigQuery. So if you look at the BigQuery architecture, it's already there. Yeah. So you can take a look, and if I go back, this is fine. Like this is storage, this is compute, and this is the petabit network which we are having, and then this is Jupyter network. And when you look at the Snowflake architecture, and we go here. In this video, I've explained in 8 minutes. I don't have time to talk about it. Like when we started in this video, it is all empty, nothing is there. It's all empty whiteboard or like blank sheet. And then after that, I evolved this during the video, and towards the end of the video, you will see that I'm focusing on the multi-layer, 3-layered architecture. So very first thing is storage layer, in which we can, that storage can be on S3, Azure Blob, GCS. So there are many different types of blob storage which are supported. And then we have compute layer. So this compute layer, we have, this is like a warehousing layer, you can say. And here we can use this compute layer for extracting data, for loading data, for transforming data. So this is on demand. So when, let's say you have a query running, then compute layer will come into picture. And like if it is not cached, right? So if the data is cached, then that's a different case. I'll talk about, there is a result cache, there is a data cache, there is metadata cache, but let's ignore caching right now. And the compute layer will come into picture. Let's say you fire a query, then compute layer, the warehouse layer will come into picture, and it will execute your query, and it will retrieve data from storage layer, and it will execute the query. So warehousing layer. And then we have cloud services layer, which is always on. It is not on demand. It is always on, and it is brain of Snowflake. And this is horsepower of Snowflake. Compute layer is horsepower of Snowflake. It's like EC2 machines, AWS EC2 machines, if you are on AWS running. And then it is virtual warehouses. So this is brain of Snowflake. So there's security management, infrastructure management, metadata management, query parsing, optimization. So a lot of things going on in the cloud services layer. So it's always on. And there is a caching also, which is happening in cloud services layer, which is called result cache. And there is another caching, which is there in compute layer, which is called warehouse cache. I hope you are getting a holistic context around Snowflake architecture. Feel free to ask questions if there are any, but I will compare caching as we move along. But right now, I'm just sharing with you that we have two different technologies, and they are inspired by different white papers. This is proprietary, and not much details are available, but there are a lot of patents which are which Snowflake is having. If you just search for patents of Snowflake, you will find, and even for Google also, you'll find a lot of patents for Google, right, on internet. But this is like, I just wanted to give you high level perspective around architecture. We don't have time to actually go into detail of each and every technology, because I have already recorded a lot of videos, so you can watch those videos. I'm giving you those pointers and references. So please take your own time, go through those videos. If you have any questions, you can always put it in the comment section in the video. We will revert back. Now, second thing is GCP. It works with GCP with full capability. Like if you are working on Google Cloud Platform, it works with full capability. Yeah. But when we talk about BigQuery Omni, so BigQuery Omni is another product. Let me show you if I can find out if it is already available or open. Otherwise, I'll search and show you. Yeah, this BigQuery Omni. So this BigQuery Omni, you can run BigQuery analytics on data stored in AWS or Azure Blob Storage. Yeah. Yeah. So this is something which is a newer functionality which has been added. So you can just go through the architecture and other things. But very important thing that I want to mention here is that BigQuery is not just for GCP, but also it supports other platforms. Now, third part is BigQuery has BigQuery ML. BigQuery ML, if you go to BigQuery ML, let me show you that. So this BigQuery ML, we can build machine learning models, and we can train, we can do a lot of things like hyperparameter tuning. So a lot of things can be done. But there are limitations. BigQuery ML is not TensorFlow. TensorFlow, Vertex AI, Vertex AI is a platform, a Google AI platform, newer version. So there we can run TensorFlow models, and we can build models from scratch. Even here also we can build models from scratch, but this is having a limitation because it is still evolving and not all the algorithms are supported. A few algorithms are supported, which are mentioned here. So supported model, that's why supported model in BigQuery ML. Yeah. So I want to mention this thing that BigQuery ML is there, but there are limitations. Not all machine learning models are supported. Snowflake integrates very well with the partner ecosystem. So there are a lot of partners of Snowflake through which we can easily implement machine learning models, right? So it's not within Snowflake, but they are outside Snowflake. Even Snowflake can integrate with Spark, and in Spark, we have Spark machine learning. So you can easily work with Snowflake data with Spark machine learning because we have Snowflake Spark connector also. Then fourth point is compute charges are based on amount of data processed. So please understand the pricing model for BigQuery is very different, and there are a lot of details to it. Let me see if I can pull out some interesting whiteboard picture so that you get an idea how we look into the pricing of Snowflake, BigQuery and Snowflake both. Actually, we are talking about both. So I want to mention this thing, that pricing part. So there are two aspects. One is called storage pricing. Another one is called compute pricing. So let's say if we talk about storage pricing, let me show you. Let me open the pricing part. This whiteboard will help you in understanding how this is organized. So you can say BigQuery pricing. When you say BigQuery pricing, there are two things. One is storage pricing and another one is compute pricing. So this is a picture from one of my virtual instructor-led class. So, so this is storage pricing. This is compute pricing. Storage pricing, we have active storage, and another one is passive storage. So active storage is something which is normal price, and passive storage is when data is not being modified for last 90 days, then data is all automatically archived by BigQuery. So this is an intelligent feature. So this is saving our cost. So the cost will go down by 50%. So that is a very good advantage of you storing data in BigQuery. Yeah, so there is optimization. Another part is compute. So within compute, we have on demand, we have fixed, we have flex. So right now, when you are looking at the whiteboard, so when you are looking at the whiteboard and when I am comparing, I am writing specifically, we are talking about compute charges. So I'm specifically talking about compute charges. Maybe we can talk about the storage also, but right now we are very clear about the specific thing that we are comparing. So the pricing model for compute charges, and that too ad hoc plan. Ad hoc plan means on demand, this on demand plan. So for on demand plan, we are having the charges based on the amount of data that we process. So let me show you BigQuery console very quickly. So if we go to BigQuery console, so this is BigQuery console. This is BigQuery console. I'll close this. And there is an editor. And I have this, and I can just bring some queries for you. So in BigQuery console, let's say I have a query related to let's say I'm pulling out query. Just figuring out a simpler query for you so that it is easy for you to understand. So let's say I'm pulling out query. This query is available on internet. So I'm just bringing that query. So let's say I'm bringing this query. This is available on internet. So I'll just switch to a project and I will compose a query and I'll paste it here. So can you see it is giving me an indication that the query will process this much data. So this is a query and it is also indicating me how much data it will process. Because when we talk about BigQuery pricing, right now I'm having on-demand plan. Right now there is not fixed plan. So when large enterprises, they buy BigQuery subscription. So usually it is based on fixed plan because we don't want surprises at the end of the month. So let's say we are right now not going for the fixed plan right now. We are talking about on-demand. So in on-demand, so when you have a query, I did not even execute the query. It is able to give me how much data it will process. And the charges are based on that. So when I am going back to the whiteboard, I want to clearly tell you that in compute charges, the query execution, the amount of data that we will process in the ad hoc plan. So we are talking about ad hoc plan because we are not having any fixed plan by default. So I just created a GCP account and there I have got some free credits and I'm referring to the compute charge and it is based on the amount of data that we process. Now, next one is compute charges are for query execution time in Snowflake. So if we go to Snowflake right now, if we go to Snowflake, this is Snowflake. And in Snowflake, I have classic UI. I love that. And then we have a new UI, which is Snow Site. So let's see, we go to, let's see the data warehouses and we go to the Snowflake UI. In Snowflake UI, here we have warehouses and I can say I want to create a warehouse and I can always choose a warehouse of required size. Let's say extra small, small, medium, large. So this is a compute layer. So this is a compute layer. If you relate with the video that I was having in the video, this video, I was having compute layer. So compute layer, there is a warehouses, virtual warehouses. So these virtual warehouses are basically a kind of EC2 machines. And these EC2 machines are of different sizes. And there are charges. How long I will be running these EC2 machines, then there are charges. It is like renting a car. So how long these will be running? So per hour, based on that, there are charges, credits, and these credits will translate to dollars if you go to the Snowflake pricing page. But I hope you are getting a sense that in Snowflake, when we execute a query, then we need virtual warehouses because this is a compute. And when we execute a query, then we need virtual warehouses, and virtual warehouses, they have costing, they have charge, and the credits are consumed. And this is for runtime. That's why per hour. It is not for the amount of data that we process. So that's what I wanted to share with you, that this comparison is based on that. If you have any questions, please let me know. Otherwise, I would also say that like it is in addition to this particular compute charge, in addition to compute charge, I would also like to say that there are two important pages which are related to Snowflake and BigQuery pricing. So please visit those pages. So specifically, if you want to understand Snowflake pricing in more detail, go to this page and see like how many credits are consumed for each virtual warehouse. And along with that, you will see there are charges for cloud services. There are some serverless features also within Snowflake. So that means Snowflake is not like buying a car, but it is like renting a car and hiring Uber. So there are features. Serverless features means you pay for the processing, for the amount of data that you process. So there are some serverless features within Snowflake. So you can go into these details, but we can have separate webinar on Snowpipe or materialized views or specific areas. But right now, just understand that we have charges, and the charges will vary from edition to edition of Snowflake. So this is standard edition. So in standard edition, we get the warehouse, the data warehouse functionalities. Along with that, we get 1 day of time travel. But if you are having enterprise edition of Snowflake, then we are having 90 days of time travel. So if you look at the if you look at this, and if you go to the top right corner, you will see I'm using enterprise edition right now. Yeah, this is available even in trial mode. So when you create your Snowflake account, you can get the enterprise edition in trial mode. So in enterprise edition, we get everything which we got in standard edition. Along with that, we get many other interesting functionalities, including multi-cluster warehouses, 90 days of time travel, and many other interesting things. So when we talk about pricing, you will see you can choose the region. So you can say, I am right now running Snowflake in AWS East, US East region, and then you can see how much are the charges per credit, per Snowflake credit, $2 per Snowflake credit. And then you can also pre-purchase the capacity. So let's say I want to buy 100 terabyte storage per month. So you can pay $2,300 for 100 terabyte storage per month. Yeah. So depending on the region, the cost can vary, but it is usually in this range, $25, $27, $23. And then this is for storage cost, if you are buying it beforehand. And then this is on demand. And then there are data transfer charges, like in case you are setting up replication or some other interesting features like external tables, external functions. Then there are some network transfer charges also. So this pricing page and these pricing examples will help you understanding. There are 2 examples which are given, but since we are having very limited time, but so that's why I cannot go through each of these 2 examples, but I would encourage you to please do read these 2 examples, because this is going to help you a lot. Yeah, how the calculation is done. And then there is BigQuery pricing. In BigQuery pricing, again, there are 2 areas. One is storage pricing, another one is like compute pricing or analysis pricing. And within analysis pricing, we have on-demand, flat rate, and then there is another one which is flex, which I was showing in the whiteboard here. Flexible pricing, in which, like, let's say you want some queries to execute very, very fast. So you can have a combination of flat as well as flex. So that means you on demand, you are asking for more resources. So please have a look. You will get an idea about the pricing part. Now coming back to the comparison. So you are clear that compute is something which is based on the amount of data processed, and another one is query execution time. But storage pricing is also there. And then there are serverless components within Snowflake. So please do have a look. Okay. So in Snowflake, when we execute query, then we have to have a virtual warehouse running in case it is not coming from cache, result cache. Let's ignore that case. So we have to have the virtual warehouse running. And then in case of BigQuery, we don't have any concept of virtual warehouse. So if I am running this query, I can directly run this query without any problem. No? So it is completely serverless, but there we are getting more control also. If you look at the virtual, we can change the size of virtual warehouse depending on like what kind of complexity we are having. And also number of virtual warehouses, we can vary depending on the concurrent queries that we will be receiving. So when it comes to concurrency, like BigQuery project, in one project, we can have 100 interactive queries. If you look at BigQuery quota page, quota and limits page, I want to talk about the limitations of BigQuery so that you can compare with Snowflake also. When we talk about BigQuery quotas and limits page, there is a maximum number of concurrent query, 100 queries in one project. So 100 concurrent queries can run in BigQuery. But you can overcome these limitations of BigQuery by setting the priority of the query from interactive to batch. So then you can scale. But those queries will execute only when there are available resources in the Google data center. But if you want to run 100 concurrent queries in which you need response ASAP, then there is a limitation in a project. Yeah. But when we talk about Snowflake, then we have virtual warehouses, and number of concurrent queries that can run in a virtual warehouse depends on the number of threads you can have in a virtual warehouse. Now 512 are also there, like you can say 512. So this one query, two query, you can imagine in that manner, you can just consider in that manner how many parallel threads can execute, and from that perspective, you can say it can go up to 512 also. And there are some interesting new virtual warehouses coming, which are highly memory optimized, and they can give very good performance. Yeah. So Snowflake is improving these virtual warehouses a lot to bring in more concurrency and more memory we can allocate to the queries depending on how much money you are okay to spend. Okay, so this is another interesting difference between Snowflake and BigQuery. BigQuery, we can't see any virtual warehouse. That means compute layer we cannot even see in BigQuery, but in Snowflake we can see that compute layer. Then any comments, any questions, feel free to ask. Otherwise, I'll move to the fifth point, which is caching. So in BigQuery, caching is only for 24 hours. And this caching, again, there is a caching page, which you can just visit and see, like there are limitations of caching in BigQuery. But when we talk about Snowflake, caching is at different levels, multiple levels. So we have metadata cache, and then we have like metadata based queries will be retrieved from the metadata base cache, and it is in cloud services layer itself. But in Snowflake, in BigQuery, the metadata is always retrieved from information schema, and this is coming from the information schemas, and you are charged for at least 10 megs or 10 MB of data in case of information schema. So this is another area. And then apart from that, caching is also, if you look at the architecture of Snowflake, let's say here, you can see there is a warehouse cache. So this warehouse cache, we have compute layer. That means different virtual warehouses are executing. So let's say there is a business intelligence team which is working. So let's say there are queries which are common to many business intelligence teams. Users, let's say there are 5 users running the same query, then the same data can be reused, because there is a warehouse cache available. And then result cache is also there, which is again cloud services there. We don't even have to go to the compute layer. So these are the results which are cached, and this is the warehouse cache, which is having the micro partitions which are cached. So the multiple users can share the cache here. So this is another important difference. Multiple levels and multiple users can reuse the cache. And then we have time travel for permanent tables. It is up to 7 days. And then we have time travel at different levels, which is up to 90 days for persistent objects. Time travel is only for tables in BigQuery, but here in Snowflake, we have time travel for other objects also, persistent, like for example, table, and then we have data sets also, like databases. So we have we have offerings related to like official courses for Snowflake BigQuery, so we can always assist you, like in case your team is interested in going through detailed courses for BigQuery or Snowflake. We will be happy to contribute. So what I'm just sharing with you, like there is another important thing right now, which is fail-safe functionality. Fail-safe functionality means like if let's say time travel period is over, 90 days are over. Now, let's say you want to recover some data, then we get additional 7 days and we can ask Snowflake support to retrieve our data, which was basically deleted by mistake, or there was some update which were made. So we can recover that data. It's fail-safe functionality, even after time travel period is over. Like we get additional 7 days. And this is done by Snowflake support. Not, you cannot do it, but Snowflake support can help you. Then we have BigQuery, which is having a vast ecosystem analytics hub, as I was mentioning. And if you go to the console of BigQuery, you will see on the left side, we have analytics hub. And let's say I leave this. In analytics hub, you will see we can share data sets. This API is not enabled, but we can share data sets securely and efficiently. We don't have to copy data, big data. And then we have other interesting areas like BI engine is another functionality, which is helping us in having in-memory cubes. So you can say this is fast and in-memory analysis service, and it can integrate very well with Looker, BI tools like other BI tools. And now Data Studio is renamed to Looker Studio. So there are BI tools which can integrate with this BI engine, and it is basically for improving the performance of the dashboards because the queries results are already cached. So this is another interesting area for caching. And then data form. Here, if you go to data form, now data ops is another important area whenever we are choosing a data warehousing platform. So data form, we can do, we can apply best practices of software engineering. So it's like a version control. It's kind of GitHub functionality, which is integrated with BigQuery now. Earlier, it was not there. So BigQuery is also coming up with a lot of new features. This data form is there. And Snowflake can easily integrate with dbt and Flyway. There are so many tools which it supports with regards to. So I did not write these things explicitly because I want you to explore and think about it when we talk about routines. So we have BigQuery routines. BigQuery routines. So when we go into the routines, you need to see the capability of your team. So this is like having, we can create routines. Yeah, we can, when we say routines, we have stored procedures, we have user defined functions, we have table functions. But when we talk about Snowflake, here we have stored procedures, right? Again, we have UDF. Yeah, and then within like UDFs also we have user defined table functions and aggregate functions. Lot of interesting areas are there, but Snowflake has these functionalities. Yeah, stored procedure UDF. So now this is very important thing to understand. Snowflake recently released Snowpark also, Snowpark functionality. So this is something which is IDE. And we can write Spark applications. Spark applications. We can build Spark applications. So you can see we have like, it's like a competitor to Databricks, because earlier companies were using Snowflake for SQL, and then they have to implement Spark projects. Then they were using Databricks. Now you can build Spark applications within Snowflake itself. So Snowpark is another interesting development that I was showing in the evolution of Snowflake. So this ID is very helpful for the developers, not just analysts, but developers can also make use of this platform. Yeah. And here you see like, when we, so please look into the languages which are supported, JavaScript, Java, SQL, so different languages which are supported. And then when we talk about secure UDFs and secure views, they are not supported. They are secure UDFs, secure views, secure UDFs are there. So what is the benefit are available in Snowflake? What is the benefit? The benefit here is like the query optimizer. It is basically for preventing the like security risks, the problems that we can get. So query optimizer can't even see the view definition when we talk about secure view. So there is a lot of theory behind it. If you just Google, and you will find in Snowflake documentation also, there is very nice example which is given related to secure views. So from that perspective, Snowflake has that functionality. And then there are data security features like data masking. So dynamic data masking is there in Snowflake. In Snowflake also dynamic data masking is there, but in BigQuery it is just getting introduced. Dynamic data masking. Data masking. What is the dynamic data masking? Let's say there is a production data and you are cloning it to the lower environment, and you don't want the people with different roles to see that data in a normal text or plain text. Let's say credit card data, or let's ignore that scenario of production data getting copied to lower environment. But let's take for very simple example. Let's say you have a table in which in the production itself, and you have some credit card data, and you don't want everyone to see that credit card information. Only few people should be able to, only a few people in a specific role, they should be able to see that data. You can restrict that. Dynamic data masking is there since long time now in Snowflake, and this is quite mature. We can define this policy. And then auto scaling. When we say auto scaling, so here we get more control with regards to auto scaling, because here we have this interesting feature. When we were looking at the data, we can scale, we can define maximum minimum cluster. We can define the scaling policy. When you drive a car, you can have a sports mode, you can have economy mode. So you can similarly choose like which mode do you want to save more money, or you want to run your queries faster. So depending on that, you can choose that mode. So it means that when you choose economy mode, then the cluster will not be very aggressive in scaling itself. But when you are choosing standard mode, then you are basically ensuring that the cluster is like scaling eagerly. Yeah, so it depends like how fast you are scaling. And in case you are interested in knowing more about it, you can join the virtual instructor session in which like there are a lot of interesting things are covered. It's all official courses, so you will gain a lot of understanding about Snowflake. Yeah, so this is fine, like auto scaling. This is auto scaling. Here we get more control, auto scaling, and this is auto scaling BigQuery. So another one is lookup queries. Support is limited because in BigQuery we can do lookup, the point-based lookup. Usually it is not a very common case in data warehouses, but if you are doing, let's say, GDPR reporting, then lookup queries are very important to you. Then you can have a search function like within BigQuery. Only one function supports that lookup query. But here in Snowflake, we have search optimization service, which supports lookup-based queries very well. And then BigQuery, if you want to do some transformation, then we have data flow, or maybe you can write your own SQL logic, and then Composer can be utilized to build that like data flow jobs, and then you are creating such kind of workflow orchestration. But in Snowflake, we have the streams and tasks which are native to Snowflake. Yeah, we can have CDC, change data capture. We can have slowly changing dimensions. We can easily implement such use cases through. And there are actually many other things, like BigQuery has 40+ partners. Similarly, Snowflake has 30+ partners. So there are many other differences. So if you give me 2 hours more, I can talk more about it, but that is not the point. So the discussion here is like high level comparison between Snowflake and BigQuery in under 1 hour. So because we are having limited time, and like we planned this meetup for an hour, so that's why like I'm just sharing my perspective comparing these two technologies. I hope this actually helps you, and this gives you a holistic idea and context behind these two platforms. And if we go to our, like, we just watch these videos, because in these videos you will find the more details about these technologies, the architecture and everything. So there are benchmarks which are available on internet, which you can go through. This is Fivetran. So every company has its own data set, has its own use case, and what kind of configurations you have chosen. So I would encourage you to look at these benchmarks also. But I would suggest like do your own benchmarks before choosing any particular data warehouse. Look at the performance, but these are some standard benchmarks which are available, which you can have a look. And we already covered the pricing aspect to some extent, but in case you have questions related to that, then you can always reach out. And there are like partners which are available. So I would encourage you to look at the partners in which you are interested in 𝐜𝐭𝐚, right? So maybe you are already having license of Informatica or Talent, and you want to integrate with BigQuery or Snowflake. Both are supported. But if you are having any specific partner which is not supported by one or the other platforms, you can have a look at the documentation, and then you will get to know more about it. So this is another important reference that you can have. So what we will do, we will put together all the links in the video itself, in the description of the video that we will have on the YouTube channel, so that you can just explore and research, and you can choose your own data warehouse, depending on the use case that you are having. So any questions that you are having that I can answer? Let me go back to the presentation. So this is what we looked into right now. We already covered semi-structured data processing support is there. So please do connect with me on LinkedIn in case you are not connected. And also please do follow our LinkedIn page. So this is our meetup group, All Things Data. So please do join that meetup group. So this is the QR code for the YouTube channel. And in case you are not already subscribed to the channel, please do subscribe to the YouTube channel. And there is a Twitter details also. You can join our Twitter page. So thank you so much for joining the session. In case you have any questions, feel free to clarify. Otherwise, we are done for the day. I'll see you maybe in the future session related to one of the greatest technology. It can be BigQuery, it can be Snowflake, it can be something else, something new. If you are interested in knowing anything specific about BigQuery or Snowflake, you can reach out to us on maybe inquiry@datacoach.io. So there we can answer your questions as well. Yeah. So thank you so much, and have a nice evening and a great weekend. Thank you, Akshat. Please do provide your feedback on the YouTube channel comments, because that would help us in reaching more people, and they can also gain benefit out of such webinars. Thank you, Mudit.